Alcohols are classified as either primary, secondary, or tertiary, depending on what the carbon that they're attached to, what's around that carbon that the OH is attached to. So primary carbon, for the primary alcohol, the carbon is bonded to just one other carbon, or one other group. So right here is the primary. So here's the OH group. Here's the carbon that we're looking at, because that's what the OH is attached to. So it has 2 hydrogen and 1 group right here. So 1 carbon. So it's primary. Okay, secondary, the carbon that the alcohol is attached to, or the OH group, is attached to, has 2 other groups attached. So 2 other carbons and only 1 hydrogen. And then tertiary, the carbon that the OH group is attached to has no hydrogens attached. It's all just carbons around it. So we're going to be able to classify these alcohols based on the carbon that the OH is attached to. We'll do that here in this example. Okay, so A, we have our OH group here. So we're looking at this carbon here. Okay, so around this carbon, we have, let's use this one. We have 1, 2 carbons attached to it. Okay, so if we have 2 carbons attached and 1 hydrogen, that means this is secondary. So this is a secondary alcohol. Okay, the OH group on B is right here. So we're looking at this carbon. Okay, this carbon is only attached to 1 carbon and it has 2 hydrogen. So this alcohol is primary. Okay. On this one, here's the OH group. So we're looking at this carbon right here. This carbon has 3 carbons attached to it. There's no hydrogen attached at all. So this is a tertiary. So tertiary alcohol. Okay. This OH group is right here. So we're looking at this carbon right there. And it's attached to only 1 other carbon, this one right here. So this is a primary. Okay, and here's our OH group here, and our carbon is right here, and it's attached to 2 other carbons. So this is going to be secondary. Okay, last one. Here's our OH group. This is the carbon we're looking at. It's attached to 2 other carbons here. So this one will be secondary as well. Okay, so alcohols can be classified as either primary, secondary, tertiary, but we're looking at what is attached to the carbon that the OH group is attached to. So alcohols contain a hydrophilic part. So hydrophilic is water-loving, and that's just the OH group. And because the OH group is polar, and so it likes water. And then it has a hydrophobic part, which is the carbon chain. So the carbon chain is actually nonpolar, so it doesn't like water. So the OH group, so we'll look at this big one here. This is the OH group right here. That's more closely related to water. It's polar, so it'll bond with water. But this other part, the carbon chain, is more closely related to alkanes because it's nonpolar. So that's why we call it hydrophilic, or water-loving, water-fearing portions of the alcohol. So hydrogen bonding, we talked about how that's occurring in the alcohols. Hydrogen bonding is strong, so the more of the OH groups that we have attached to the alcohol, the higher the boiling point of the alcohol. So ethanol, which only has one OH group, has a boiling point of 78.3. And then ethane diol, which has two OH groups. So remember, diol means we have two OH groups attached. The boiling point is 197. So that's quite a big difference there between one OH group and two OH groups. Okay, some other things is methanol, ethanol, and propanol are completely soluble in water. So that means methanol, ethanol, propanol will dissolve in water. So if you think about it, those are the three that have the smallest carbon chains, right? So methane or methanol is CH3OH. Ethanol is CH3CH2OH. And then propanol is CH3CH2CH2OH. So after that would be butanol, which has 4 carbons, and then pentanol, which has 5. So the bigger that carbon chain is, the less soluble it is in water. But these smaller alcohols right here with the smaller carbon chains, they will completely dissolve in water. And then methanol and ethanol can even dissolve small amounts of ionic compounds. So right down here. So for example, sodium chloride is an ionic compound. Okay, so methanol and ethanol can dissolve small amounts of ionic compounds. And they're also miscible, which means they dissolve in organic solvents as well. Okay, so we're going to look at some reactions of alcohols. First one we're going to talk about is dehydration. When alcohols are treated with a strong acid, a water is lost and it yields an alkene. So we're going to go from an alcohol to an alkene. So the OH group and the hydrogen is removed to produce water, and then a double bond is formed between those two carbons that lost the hydroxide group and the hydrogen. So in our example here, so here's the hydroxide, and only one of these hydrogen here are going to be taken, not all three of them. Okay, so one hydrogen, the OH group, those come together to produce water. And when it loses those, the double bond is formed in between the carbons that lost the OH and the hydrogen. So we get that double bond here. Now, sometimes you'll get a molecule where there are multiple places that the hydrogen can be removed. And if that is the case, then you'll actually have a mixture of products form. So here's an example. Okay, so here's the OH group. So we can either take a hydrogen from this carbon or a hydrogen from this carbon. Okay, so if we take a hydrogen from this carbon, then the double bond forms right there between the two carbons, like it's shown right here. Okay, and then if the hydrogen's taken from this outside carbon, then the double bond is formed at the end. So both of those products are formed, but the one that's formed the most is this one in the middle right here. Okay, this is the major product. So Ch3's rule states that the more substituted alkene is the major product of the reaction. So they'll both be produced, but because we have two methyl groups here on the outside, it has more substituents than over here, which only has one. Because it has more substituents, it will be produced the most. Okay, so let's look at this one. What are the major and minor products that are produced? Okay, so we're going to take the OH group here, and our options to take a hydrogen is from this carbon in this carbon, okay? So again, it's gonna produce both. So we'll start with this carbon here. We'll redraw that. So we're gonna get a double bond between the two carbons. And then we'll have a methyl group coming off here, another methyl group coming off here. And then on this side, we will have an ethyl group right here and a hydrogen here. So this will be produced. And now let's look at this one. Okay, we would have CH2 and the double bond. Well, let's draw it like this. Okay, we have CH2, the double bond to the carbon. We'll have a methyl group down here and a propyl group right here. So here, we only have 2 substituents. Over here, we have 3. So this one here will be the major product. So mostly this is what's going to be produced. We will have some of this other one produced as well. Okay, we also have oxidation, and when primary or secondary alcohols are treated with an oxidizing agent, they lose one or more hydrogen from the carbon bearing the OH group, and it forms a carbonyl containing compound. So the carbonyl containing compound is a functional group where a carbon is double bonded to an oxygen. So this example right here shows us, so here's the alcohol, here's the OH group. So that's removed. A hydrogen from our carbon is removed to produce, or I'm sorry, not the whole thing, just the hydrogen. That hydrogen's removed and this hydrogen's removed to make H2. And then a double bond is formed between the carbon and the oxygen. So this is what we get. Okay, a carbonyl compound. So carbon double bonded to an oxygen, that's the carbonyl. So some common oxidizing agents that are used, we actually used one in lab. If you've been to lab yet for the alkene lab, the one we used was potassium permanganate, the purple compound that you used. Also, you can use potassium dichromate or even just oxygen gas. So it doesn't really matter which specific reagent is used in the reaction. So a lot of times what you'll see is just this symbol right here above the arrow representing some type of oxidizing agent. So a general oxidizing agent. So that's what that means. Okay, so if we have a primary alcohol and it is oxidized, then it does form the carbonyl like we were talking about. So this is actually called an aldehyde. Oops. So this portion right here is an aldehyde. So let me just redraw that a little more simple. So an aldehyde has a carbonyl group with the hydrogen attached. So the R group just represents the chain, right? Whatever group is attached. So that's an aldehyde. Okay, but you can further oxidize the aldehyde into a carboxylic acid. So the carboxylic acid, I'm out of room, so I'm going to write it down here. Looks like this. Not double one. The R group with the carbonyl with an OH attached to it. Okay, so oxidizing a primary alcohol will change it into an aldehyde. Oxidizing it further will change it into a carboxylic acid. Now, secondary alcohols, they can also be oxidized, and they are converted into a ketone. So a ketone, I'll draw this one over here, is a carbonyl with 2 R groups attached to it. So it looks a little bit different than the aldehyde. Instead of a hydrogen, we've got another R group. So we go from the OH to the double bond with the O, and here's the 2 R groups for this ketone. Now, tertiary alcohols do not contain hydrogen on the carbon, right? So it's not going to be oxidized. We only have the OH group, but no hydrogen on our carbon, so we can't form that carbonyl, so there's no reaction. Okay, tertiary alcohols are not oxidized. Okay, let's try this one here. What is the product of the following oxidation reaction? So this is a primary alcohol, right? So that's the first thing we want to establish. It's a primary alcohol. So when it's oxidized, the hydrogen from the carbon, just one hydrogen, and the hydrogen from the oxygen are removed, and then we get CH3, C, the double bond O, and then H. So that's our aldehyde. And then if we further oxidize it, we get a carboxylic acid, which would be CO with the OH group instead of just the hydrogen. So this is our carboxylic acid. Okay, so do know that for primary alcohols, they oxidize into an aldehyde and then further into a carboxylic acid. And then for secondary alcohols, they oxidize into a ketone.